For those of us who are just entering the room, we're working on our review. You have about 2 minutes left. So we have about 1 minute left on our review. I see some scholars are ready. I see many scholars have their pencils to the paper. All right, in 20 seconds, we're gonna come back. We're gonna put our pencils down. All right, everyone, pencils down, eyes on the screen. I'm gonna reveal the answers to the review questions. Okay, so perimeter measures the total distance around the outside of a figure. An example of let's go back up. Quincy, oh, I guess I'm not going to be able to draw on the thing today. So perimeter measures the total distance around the outside of a figure. Area measures the amount of two-dimensional surface that a figure covers. And volume is the number of unit cubes that fit inside a space. So volume is three-dimensional. Who can, let's see, let's go ahead and remind ourselves for the formula for the area of a rectangle. The formula for the area of a rectangle. I'm looking for hands up. Great, I see Sonovia's hand, I see Eric's hand, I see Silas's hand, Lissandra's hand. Let's go with Katie. Thank you everyone who raised their hands. Katie?
Yeah, area equals length times width.
Area is equal to length times width. What about the volume now of a rectangular prism? 4 hands are up, 5 hands are up. Let's go ahead with Nana. Nana, the volume.
For volume, it's length times width times height.
Thank you, Nana. Exactly. Length times width times height for volume. And perimeter? Perimeter is the length around all of the sides. So 2 participants' hands are up. Let's go with Synovia.
It's length plus width plus length plus width.
Yeah, length plus width plus length plus width. However many sides you have, so you add those lengths together. So you would add this length with this length with this length and then this length. Add all the lengths around the sides. So that's what we're going to be using today. So I'm going to model this I do problem for you guys. We have a rectangular prism, which is composed of 6 faces, 2 squares, and 2 rectangles. The squares measure 3 inches on each side, and the rectangles measure 3 inches by 6 inches. Which of the following statements is true about the figure? So as I read this problem, I noticed that this problem is asking me to find which statement is true. It also shows, it tells me the different dimensions of this figure. It tells me that it's a rectangular prism, and it tells me the dimensions of the faces of that prism. So what I'm going to need to do is I look at the answer choices and see that each choice gives both the surface area of the figure and it gives the volume of the figure. So I'm going to need to check each of these answer choices and see if they match the true surface area and the true volume of this rectangular prism. A really useful strategy that we practiced yesterday, I'm going to use right now, and that's going to be to draw, and in this case, show on the PowerPoint the shapes that make up the figure. So give me a strong hand. What are the shapes that make up this figure, and what are their dimensions? Looking at the problem that you have on your screen, what are the shapes of the figure, and what are their dimensions? Joseph, I see your hand. Go ahead.
I think the dimension of this is so probably like for the square, since I know each side on a square is equal, it has to be 3 times 4, so that's 12 for every square. So for
Pause for a second. You said each side on a square has to be equal? Mm-hmm. Meaning what? The same, all the lengths are the same size? Are the same length for a square?
Yeah.
Okay. And then you said 3 times 4. Are those the same?
Wait, repeat that?
Yeah, you said that the square lengths have to all be the same, and then you said that the sides would be 3 and 4.
No. The sides would be 3 times 4. I mean, right. Like the total of every side.
The total of every side. All right. I'm going to draw a picture. Give me a thumbs up if you're able to see on your screen this square that I just drew. Thumbs up. Can anyone see this square? Esther can see it. Eric cannot. I see thumbs up. And some people cannot see it. You may need to scroll through the chat to see the picture, to see my picture. But we're gonna take a look and we're gonna see the pictures right now on the PowerPoint. So let's do that. So the squares are 3 inches on each side. If we look at the problem, it says that it's made out of 2 squares and 4 rectangles. The squares measure 3 inches on each side. That means that here we have 2 squares, and we need to label them each 3 inches because the problem tells us that they each have size of 3 inches. We have 4 rectangles. So the next thing we're going to do is we're going to draw 4 rectangles. Once we draw the 4 rectangles, we go back in our problem and we look at the dimensions that they tell us for the rectangles. The dimensions for the rectangles are 3 inches by 6 inches. So we can label our rectangles 3 inches and 6 inches. Now we have all of the faces of this rectangular prism. I find the area, so the 2 things that I need to do are find the area, the surface area, and find the volume. So to find the surface area, what will I have to do? So Nova, you have a hand up.
Oh, yeah.
What
Okay,
will we do to find the surface area now that we know all the faces?
Since you know all the bases, then you need to add up the areas of each shape. Like once you've drawn the net out and then you figured out the dimensions of each shape, then you add them together to get the surface area.
Yeah, exactly. And we reviewed earlier that the area of a rectangle is length times width. So 3 times 3 is 9 inches squared. Each of these squares has an area of 9 inches squared. And then if we were to do the rectangles, we would do 3 inches times 6 inches. So on your screen, you should see that the area of each face has been filled in. Now we know the area of every single surface of the rectangular prism. If we add them all together, we should get the surface area. So one way of adding them all together is realizing that we have 2 times 9 inches because we have these 2 faces, and we have 4 times 18 inches. (18 inches plus 72 inches), and we have our total area for 90 inches. Are we done? Are we finished with our problem yet? No, because we remember that there's 2 parts to this problem. We also need to find the volume. So going back to what we reviewed, I'm going to call on Quincy. Going back to what we reviewed earlier, how can we find the volume? What is the formula for volume of a rectangular prism?
Length times width times height, or base times height.
Length times width times height, or base times height. Can you say a little bit more about that? The base times height. Can you, what is that base that you're talking about?
The base is the length and width multiplied by each other.
Yeah, the base is the area of the base. And then you would multiply the area of the base times the height of the rectangular prism. So if we were to if we were to take all of our faces, we can imagine arranging them and building a rectangular prism out of them. And so on your papers, what you might do is take a net and like fold it up backwards. Show me, give me a thumbs up if you remember working on nets. Nets are those flattened out 2-dimensional versions of a 3D figure. So what we just did was we basically took the 2D faces and we put them all together so that we can now have a 3D representation. Using this 3D representation, we can find the volume of our prism. I'm going to call on someone to tell us what mathematical statement we're going to use. What will we plug into our formula, Esther?
What we would plug in to our formula is that what we would do is we have to add in the units in the formula.
Yeah, you can do. I'm not sure what you mean by that.
So do we put the units of the prism into the formula?
So the formula that we're using, which we just reviewed, was that volume is equal to length times width times height. And we have those dimensions. Are you able to see those dimensions on the screen?
Yes.
Okay, so let's plug those into that formula, and then we'll have basically a number sentence that we're going to use to find the volume.
Okay, so what we would do is 3 times 6 times 3, which the 3 is the width and the 6 is the length, and then the 3 is the height. We can find the volume of the prism.
Absolutely. The volume of the prism is the length times the width times the height. And so it's going to be 6 inches times 3 inches times 3 inches. That might be what you were asking, Esther. Should we include inches in the formula? Technically, yes, because these dimensions have units. So absolutely. 6 times 3 times 3 is 54 inches cubed. So now we've done the two things that we needed to do. We found the surface area and we found the volume. So the surface area was 90 square inches and the volume is 54. If we go back to our original question, everyone scan through. Remember that our surface area is 90 and our volume is 54. Show me on your hands. Let's practice this gesture. We're all going to put up a fist. 1 for A, 2 for B, 3 for C, and 4 for D. Fists up. Everyone show your answer. Got lots of 2s. Great. 2 is B. All right. Let's move into the we do. So you should have the we do in your Scholar packets. We do number 1. We're all turning in our Scholar packets to we do 1. We have a company which is creating a rectangular prism that must have a volume of 6 feet. The company also knows that the area of the base must be 2.5 feet. What is the height of the prism? So let's go through our mathematician's plan here. We need to ask ourselves, what is the problem asking us to do, what we know, and what we need to find. Bintu. What is this problem asking us to find?
Is asking us to find how high is the prism in square feet.
It's asking us how high is the prism, but it wouldn't be in square feet, Bintu. Height? Think about the units of height.
It's feet.
Feet, exactly. So yeah, we're looking for the height of the prism. What things do we know? Everyone should be thinking about what we know right now, what the problem is giving us, and I'll call on one scholar. Muted. Miss Silla, if you can find Ben, thank you. Katie, thank you for your hand. I got your participation earlier. Let's get another hand here. What do we know? Three participants. Let's see. Why can I not see your hands?
Kiara,
Silas.
Naya.
Okay, go ahead, Silas.
and yeah, Cassandra.
Basically what we know in this problem is that the total volume of the rectangular prism is 6 feet cubed, and we also know that the area of the base of that curve is 2.5.
Right. So what formula do we also know, which is going to be useful? I want you all to think about this and write it on your paper. What formula do we know that is going to be useful for us in solving this problem? Take 10 seconds to write a formula, which is going to be helpful to write this problem, and then I'm going to call on Elijah. Okay, Elijah, what formula do you think that we can use in this problem?
Okay, so I believe I believe that what we should do is divide the overall.
I'm gonna pause you there. I'm gonna pause you there because I'm not saying you're wrong, but the question that I'm asking is what formula. So for example, the formula for the area of a rectangle is length times width. Right? What formula? Because when we do our strategy work and we're listing things that we know, something that we know is we know that there's a formula that relates to things that we care about.
Oh, so the formula is the area divided by, wait, no, the volume divided by the area. Well, V divided by A.
Okay, keep going. V divided by A. V divided by A. A formula needs to have an equal sign. So V divided
Equals
by A
H.
equals what?
Equals H.
Equals H. That is actually that's absolutely correct. Usually, the way that we reviewed it earlier was that that area times height is equal to volume, and Elijah just gave us the formula in a slightly rearranged way. So that's absolutely right, Elijah. So we know that the volume is equal to the base area times the height. Let's go ahead, everyone now, you should be able to, let's go ahead and plug in the values that are given to us in the problem. So look back into the problem. You know the base area and you know the height. So you can fill those into your formula. I misspoke. You know the base area and you know the volume. Plug those into your formula. Quincy, we need you to come back on video. Okay. So going back into our problem, we see that the volume has to be 6 cubic feet and the base area is 2.5 feet squared. The thing that we're looking to find is the height. Come up with a, what is your plan to find the height now? The last step for finding the height. Everyone is taking, I see some hands already. Take 15 seconds to write down on your paper how you will find the height. I see Bintu's pencils on the paper. Katie and Sonovia, Naya have pencils on the paper. Anthony, I can't quite see your face. Can you please sit up and make sure that you're visible on the camera? Okay, Nana, what is our final step?
My final step will be to divide, well, 6 divided by 2.5, because I know that that the area is length times width. So we already have that, and we're looking for the height. So in order to find the height, we need to divide.
Absolutely. We're going to perform the inverse operation in order to find the height. Everyone go ahead and solve for the height. Josue, you need to readjust your camera. We're just getting a nice view of the ceiling. Lemuel's hand is up. Let's take another 10 seconds to finish your calculation, and then we're going to Lemuel. Lemuel, before you give your answer, I want you to explain what you had to do to divide these two numbers, since one of the numbers is a mixed number.
But I didn't get the answer. I was just raising my hand for.
Okay, what's your question?
No, the question to answer the question before.
Okay, all right. Let's go to a participant that has their hand up. I want you to tell us what we need to do to divide these two numbers, since one of them is a mixed number. Naya, go ahead.
One second.
Naya,
Okay, so first,
go ahead.
okay, so first what I did was that basically I put 6, so I was dividing 2.5. I turned 2 1/2 to a decimal, which is 2.5, and then I did the standard algorithm. So I did 2.5, and then I put 6.0, and then I where the decimal point was, I moved it back. I moved it back to like here, to here, and then I divided 6 point, and then the 6 turned into 60. Then I divided 25 divided by 60, and I got 2.4. So my answer was 2.4.
Okay, your answer was 2.4. So Naya used the standard algorithm. She turned them into decimals and used the standard algorithm. Another thing which you could do is you could turn 2 1/2 into an improper fraction. That improper fraction would be 5/2. And you'd be doing 6 divided by 5/2. When we divide with a fraction, we need to keep change flip. So the answer is 2.4 feet in height, which if you have that as a fraction, that is 2 2/5. Show me on your hands who got the answer 2 2/5 or 2.4 feet. Give me a thumbs up. Only a thumbs up if you got 2.4, which is 2 2/5. Okay. All right, what we're going to do now is we're going to let's do a quick share out. I'm going to ask one person to explain what surface area measures and how we find it. And then I'm going to ask another person to explain what volume measures and how we find it. And then we're going to move into IP. So surface area, Alejandro, what is surface area and how do we find it?
Surface area is the area inside of a shape, and we find it by multiplying the length by the width.
Okay, thank you, Alejandro. Let's add on to Alejandro. Alejandro's he's on a good track. He's talking about multiplying length by width, and that does give us the area of a two-dimensional figure. But if we're thinking about a 3D prism, how do we find the surface area of everything? Alejandro, if you want, I can come back to you. I'm coming back to you, Alejandro. How do we find the surface area of every surface on the prism?
I think we like make make a net, and then you put the same measurements, and then you find the area for one shape, and then you add them up, and then if it's a rectangle, like you add them all up.
Yeah, one strategy would be to create a net. With your net, you can find the area of every single side. If you have a nice 3D figure drawn out, sketched on your paper, where you have all of your dimensions, you may also be able to do it that way if that works visually for you. But the point is that you need to find the area of every face and add them all together. Volume. How do we find the volume of a rectangular prism? Volume of a rectangular, Aubriana, volume of a rectangular prism.
We found the volume of a rectangular prism by we are needing to measure the unit cubes in order that fills up the 3D shape, and the equation for volume is length times width times height.
Thank you, Aubriana. Yes, see how many unit cubes can fill the prism. Your formula is length times width times height. With that information, let's move into independent practice. So I want to see everyone's pencils are on the paper. We have 6 minutes left for IP. I'd like everyone to do their best to get through questions 1 through 3. 1 through 4, if we can. Get through 1 through 4 if you're able. Okay, for anyone who does not have the packet right now, what I'm going to do is I'm going to pull up the IP on the screen share. So the first problem from IP is now on the screen share. Anthony, I don't see you doing what you need to be doing. Anthony, fix the camera and come back on video. Quincy, are you sitting at your desk?
He has to go to the bathroom.
Okay, thank you, Miss Ella. Anthony, chat to me your question. I'm going to move to this. Well, we only have about a minute left, so we're going to come back together. So take another 20 seconds to finish what you're working on at the moment. Okay, so today we were able to, we solved some real world problems. Let me just take a look here and see. Brianna, pencil off the paper, please. Let's get all eyes on the camera. Zenobia, eyes up. Nana, are your eyes up on the camera? Thank you. So today we solved real world problems that involve the surface area of rectangular prisms and the volume of rectangular prisms. We used some of the problem solving strategies that we used yesterday. We also worked in this, and in your homework, there will be some work with perimeter, area, and volume. What strategies I want everyone to think and write down. What strategies did you use to help you solve problems during independent practice? Those same strategies that you're going to take with you when you do your homework. Take 15 seconds to write down the strategies used. Okay, everyone, it's time for your first break. Thank you everyone for joining me during this math lesson today. Your homework is homework, and your advisors will be checking that tomorrow morning. Remember to come back for your next class, which is textual analysis at 10:10.
Before everyone leaves, please use this break time to charge your devices. Make sure your internet's connected so that when we come back, you're ready to go for your next classes. Make sure your devices is as charged as possible so that it can last you through the rest of the day. If not, have your chargers on standby nearby so that you can charge it and get back to work, okay? All right, enjoy your break, guys. Bintu, I'm gonna give you a call.
I'm gonna stop recording now.
Bye.